Hello everyone, welcome to my YouTube channel Easy Programming. I'm Naveen Mishra and I'll continue teaching you how to write programs in C++ language. In my previous video I have covered the topic of inheritance and told you basics about the basics of the inheritance. In this video we will continue with some tougher topics of inheritance like ambiguity and what is the motive of the access specifier that we define during the declaration of class in inheritance alongside the constructors in child class and ambiguity. Before you start watching this video tutorial, I would like you to suggest to watch previous videos of inheritance and class object so that you guys can come to know how the inheritance and how the other simple things are working out. So let's start with this video. Let's start with a topic related to access specifiers. As you guys know that we can inherit a class using private, public or protected keyword during the inheritance. So you see, when we inherit a base class in child class, we use the following syntax: class keyword, then the child class name, followed by the colon, and then the access specifiers like private, public and protected, followed by the name of the parent class, and you write the code here. So you specify the private, public, protected here, but what does that mean? The access specifier here decides the inheritance type, that is either private, public or protected. The access here specifies the area where the public and protected members of base class will be copied. That is, this access specifier does not mean that you are inheriting this access of parent class to child. Actually it means the parent class private, public and protected data will be copied in this access of the child class. Okay, in private inheritance the base class data is passed to the immediate child class only. Now you will see these differences, but you can have a quick review about these inheritance types. So if you use the keyword private during the inheritance, then only child class can access it. If you use the public inheritance, then only the base class data can use it and in the immediate child classes, and same as the protected inheritance. I'll write a program for you for this, you guys, and I hope you guys understand that better. So let's start. I have written a small program for you guys. I will teach you how it is working, and then we'll give you the meaning of the access specifier written here. So I have declared a base class, defined a base class in which I have defined three access: private, public and protected, and I have created three functions in 3ss: function 1 fun1, function 2 fun2 and function 3 fun3. These functions are in these private, public and protected access, and I have just written a simple message here like inside base private access, inside base public access, inside base protected access. So these are the class, these are the functions or methods of base class. Then I have created a derived class and inherited the properties of base class in public. And then again I have created three more functions: fun4, fun5, fun6, that is function 1, function 4, function 5, function 6, in the various access of derived class. Now let's try to use it and work it. Okay, so in the main function, as you guys know, we will only declare object of derived class. So I'm using derived d1. So d1 is the object of the derived class. Now this d1 can call fun5 of the class, that is obviously because the objects can access the public members only, so this will work perfectly. And d1 dot fun2. Now fun2 function is in public access of base class and it is inherited in public access of derived class. So your d1 object can access private, public data of its own class as well as the child class, so it will also work perfectly. But you cannot call d1 dot fun1 because fun1 in the private access here, and this you cannot do this in any case. Even if you are creating an object of base class, even then you cannot call this fun1 functions, but yes, you can call them indirectly. So let's try to run this program now. Now you see the messages that base public and derived public access are working fine. Okay, now what if I do this? Before that, what if you want to call this fun6 and fun3 functions? Now you can do this by calling the functions from other functions. Like you can call the fun6 function from here, and you can call the fun3 function from here as well. Okay, so there you go. The public and protected accesses of base class is also working, and derived protected access. You can also call the fun2 from here, fun4 from here. Let's see if it works. Yeah, you can call, but you cannot call fun1 because function 1 is in the private access and the private members of the class will not be passed in any way to the derived class. Okay, so you cannot do that. Now what if I change the access of this public to private here? So I am using public, changing the keyword from public to private. By doing so, the private members will not be inherited, but the public and protected members of base class will be passed to the private access of derived class. And since the data is passed in the private class, this fun2 will not work. You see, fun2 will not work because the fun2 function is passed in the derived class private data, and private members cannot be inherited by the cannot be used by the objects. Okay, rest of the things will work. That's not an issue. And what if I do the protected? Then again it will do the same thing. That is, the private and protected members of the class, public and protected members of the class are passed to the protected access of the derived class. Okay, so this will work fine. The difference between private and protected will work in the third access, like class derived to colon public derived. Now since you are passing the value, passing this derived access members to this derived 2, indirectly base class members will also be passed to the derived 2. So if you are using the private inheritance, then creating the object of derived 2 and calling the, now you see fun2 3 5 6 will work, 2 3 5 6 will work, but I don't think you can call fun2. Let me see. Yeah, you cannot do that because fun2 is in public, which is passed to the private access of derived, which cannot be passed further to the derived object. Now but if I change this access to protected or public, let's say public, then definitely it will work. Okay. Or protected, then it will also work. No, protected data is passed. Okay, I can call it from here as well. Like I can create a public method and I can create another function 7 or whatever name is, and I can call the fun2 from here, as the objects cannot access the protected members. Let's see if it works. There you go, it works fine. So let me show you graphically how the things will work. Now let's say you have a base class and you have defined 3 access, private, public and protected. Then you are inheriting this class privately, publicly and protectedly. Irrespective of this keywords, the private members of the class cannot be passed to the child classes, as I have shown you in the program. If you call these members, if you put the inheritance, if you implement the inheritance using a private keyword, then public and protected members of the base class are passed to the private access, which cannot be used by the objects of the child class. And same, if you use the protected keyword, then these two accesses data will be copied to the protected access of the child class. And if you do the public inheritance, then public data of base class is copied to public of derived class, and protected data of base class is copied to protected data of child class. So this is the importance of using these keywords, private, public and protected. You guys must know about this. Now let's continue. Ambiguity. Now ambiguity is also a very important topic, and lots of BC and BTech computer students will have to face this in their programs or in practicals. Okay, so let's start about the ambiguity. If the base class and the child class both have the same function name with same number of arguments, then it is called ambiguity. In such cases, the function in child class overrides the method in base class and the base class function becomes ambiguous. This is also called method overriding in Java, or you can also say it in the C++ as well. Now ambiguity can occur in two types of inheritance, that is in single level and in multiple inheritance. In single level, the base class and child class both have the same function name with different definitions. Now let's try to understand this. I will write a program for this as well. Let me see if I have done this. There you go. So again, I am saving some of my time by creating this function for you guys in advance. So again, this is a base class and I have two functions, fun2 and fun3, in public and protected member of the base class. And the derived class inherits the properties of base class using the public access, and inside the public and protected members it is again creating the functions. Now you see here, this function 2 is repeated in the derived class again. Now when we create the object of d1, and when I call this function d1.fun2, there is a confusion for d1 that whether I should execute this fun2 and print the message base class, or call this fun2 and print the message derived class. Now in such case, the definition of this fun2, that is of derived class, overrides the definition of this fun2, and this fun2 function becomes ambiguous. So in such case, this derived public access message will execute. Let me try to execute this and show you the message. There you go, inside derived public access. So when you implement same function name with same number of arguments in base and derived class, then derived class function will execute and not the base class function. The solution of this is, even if you want to still call the function of base class, then you can do this d1 dot base followed by scope resolution, then fun2 again. Now this base is the name of the base class, followed by the fun2 function. Let's see if it works now. And there you go, the base public access will also work. So the solution of ambiguity in single level is using this base keyword class name followed by the scope resolution operator. Now ambiguity can also occur in multiple inheritance. Now if the child class have more than one base classes, and these base classes have the same function name with same number of arguments, then it is also called ambiguity. In such case, compiler will generate compile time error when such functions are called. Let me show you that as well. There you go, ambiguity in multiple. So I have created a base class and another base class base2, which are sharing same function name fun2 and fun2, and when derived class inherits both of these base classes, then it have two different copies of fun2, and if you try to call this d1.fun2, it will generate a compile time error. There you go, this is a runtime error that fun2 is ambiguous. Okay, so you should avoid this, but in such case, if you want to call the functions, then you can be specific using this class name and the scope resolution operator. Let me see the output. There you go, the base to public access works. And if you want to call the other base class function, then you can do this base scope resolution fun2, and this will work as well. There you go. So both base classes public accesses can be executed using this solution class name followed by the scope resolution, and this is I have shown you here as well. Okay, so ambiguity can be in single level or can be in multiple, and both the programs I have shown you and implemented it. Now there's another topic, path ambiguity. Let's understand the path ambiguity now. Let's say we have this situation where a grandparent class have two child classes, parent class 1 and parent class 2, and these parent classes have a common child class here. Now the parent class data is copied to child class as well as the parent class 2 data is copied to child class, but the grandparent data is passed to the child class by two different ways, by two different paths, one from here, another from here, and it can also call the members indirectly using this, directly using the name of the grandparent class. So in the above type of inheritance, the variables and methods of grandparent class are passed to parent class 1 and 2. These parent classes are further inherited by the child class. The child class will have duplicate copies of grandparent class. Okay. Now we need a solution of this as well. So what we can do is we can use a virtual keyword. So during the declaration of the class using the access specifier, you can use the virtual keyword to do this. This virtual keyword makes sure that only one copy of grandparent data is passed to this child class. You can use keyword public virtual or you can use keyword virtual public. The order is not important here. Okay. Let's try to write a program for this and let me see if it works. I'll save some of my time. So this is base. I'll name it grandparent. I'll only use the public methods. Then I'll create a parent1 class which will inherit grandparent data and will have a different function here. I don't need this. Then I will use another class, so I'll copy this code again. And I'll use parent2 here, and it will have another function 4. And derived will call both of these, parent1 and parent2. Then I'll create the object of this and let's see if everything goes fine. I have to use this, remove this protected. Let's try it. fun2 is ambiguous. Okay, so have I used this fun2 again? Yeah, no, I have not redefined it, but actually this fun2 is ambiguous because of different duplicate paths. Now let's try to call another comma public grandparent, and let's see, it will still give you the again message that fun2 is ambiguous. Okay, so let me use this virtual keyword. I can use virtual public or I can use public virtual, and let's see if this problem is fixed. Okay, fun2 is still ambiguous. Okay, I have to remove this and let me see if this problem is fixed. There you go, the problem is fixed. Okay, now what if I use this virtual again for grandparent, and let's see if it works. Yeah, so the virtual keyword is the solution for you guys if such scenario occurs that the data of grandparent is passing to the derived class from multiple paths. Okay, so this is the virtual keyword. Now let's start with constructors. Constructors in inheritance. As you guys know, the constructors are normally called when the objects of the class is created. But in inheritance, we create the object of child class and not the object of base class. As you guys can see, we are creating the object of derived only and not the object of other classes. In such cases, how the base class constructor will be called? Now let me show you that as well. Okay, I'll remove this. I'll copy this, and I will simply write a message here. End of the class. I don't need this x variable as well, and I'll do the same here. The show function now. So there you see, guys, I have a base class in which I'm creating a constructor, and in the derived class I'm calling and the derived class I'm inheriting these properties and creating the constructor of derived as well. When I create the object of derived class, definitely this constructor will execute. But what about this constructor? The C++ compiler automatically calls the base class constructor first and then the derived class constructor. So let's see. There you go. So base class constructor is executing first and then followed by the derived class constructor. So the constructors of base class is automatically called, right? The compiler will execute the base class constructor first and then the child class constructor. This will work automatically for default constructors. But what about if you have multiple constructors? You see here, if you do this, class parent 1, class parent 2. Now let's say I have another base class. I'll copy this and name here. Okay, so I'll change just the message, and here I'll call base2 as well. Now this is the constructors in multiple inheritance. What will happen here? You're creating the object of d1, derived d1, and I have told you that base class constructor will be executed first. But which base class constructor first? Because I have two base classes. In such case, the order matters here. Since I am calling base first and then the base2, the same sequence will be followed. Base, base2, and then the derived. And if I do this, that base2 is called first, followed by the base class, then this sequence is followed. So there you go, base2, base and derived. So the compiler will follow the sequence that the programmer mentions in this line. Okay, so this is the constructors in multiple inheritance, and I have shown you this output. Okay, now what about if your constructors have arguments? The base class constructor is parameterized constructor, explicit calling of constructor. If the base class constructor have parameters, then the derived class constructor must call it with a parameter. Now it cannot work for implicit constructors. Implicit constructors with no arguments were automatically executed by the compiler, so that's why they are called implicit constructor calling of implicit constructor calling. Now if your constructor have arguments, then you have to call it specifically. I have written a program here. As you guys can see, this base class have an x variable, and inside the constructor it is receiving an argument and passing it to x variable. Derived class inherits the properties of base class. It has a y variable and it is passing two parameters. Now you have to use this colon and base. Now this is the explicit calling of the constructor, and you are passing the value of a to the base class constructor, and simply I'm printing these values, and d1 derived d1 object is passing these two values here. Okay, and this is the output of your program. So base class constructor will be called first and x value will be set, and then the derived class constructor will be called and y value is set. Then when I call the show function, then these x and y values will be shown. Now when I did this 10 and 15 are passed to a and b, and then from here this 10 is passed to I, which is copied to x, and the x data is printed, and this b value is copied to y and y data is printed. Okay, this is the program of derived classes I have written for you guys. what I can do is I can do this as well. I can simply say that just call the constructor with this value, and a derived class constructor can be of default size of default constructor. So derived constructor is default, but when it calls the base, then it passes a number to this base class constructor, and this is the explicit calling. Okay, just a second, I had to correct some things. Let's try to run this file. There you go, it works fine now. Okay, but random data is shown for y because I'm not passing any value from y here. Okay, so these are the constructors in child classes. I think that's enough from the inheritance. I have covered all the topics, small or large, related to inheritance in my videos. If I still missed some topics, you can comment in this video tutorial, and I will get back to you. So that's it from this video. Thank you very much for liking or viewing my video. I will like you guys to please subscribe and share to my channel. Thank you very much. See you in the next video. Cheers.